Hello everyone. In this video we're going to try to verify this identity. So we'll go ahead and start on the right side and try to work our way to the left side, since there seems to be more we can do there. So for the proof of this identity, we start with cotangent squared x minus 1 over cotangent squared x plus 1. We'll go ahead and rewrite each of those cotangent squares using cosine and sine. So we know we can write it as cosine squared x over sine squared x minus 1 over cosine squared x over sine squared x plus 1. So notice that if we go ahead and think of a 1 under each of those 1s, we can go ahead and combine the fractions on the top and bottom of this complex fraction. So we end up with having to multiply top and bottom of the 1 over 1 by sine squared x, and the same down here. So we end up with cosine squared x minus sine squared x over sine squared x over cosine squared x plus sine squared x over sine squared x. So now we can do the outer product over inner product, because we have just one fraction over one fraction in the form of a over b over c over d. And we've discussed in other videos that you can do this kind of shortcut, AD over BC. So we end up with sine squared x times cosine squared x minus sine squared x over sine squared x. That's the outer product there on the top. Now this is the inner product over cosine squared x plus sine squared x. Now we know that this expression here is 1, and we also know that the sine squares can cancel out. So basically we end up with cosine squared x minus sine squared x. Notice that you can write that as cosine x times cosine x minus sine x times sine x. That should look familiar to you. That's the cosine of x plus x, which is the same as cosine 2x. And there we have established the identity. So part of the reason that I did it in this fashion was because this was a step-by-step type of problem on the software that you're using. But just as an alternative, you could have handled this a bit more quickly if we were not going through one of those step-by-step situations. So from this point, I'm going to show you an alternative approach. What we could have done, instead of finding common denominators, etc., the most efficient way actually of clearing, so I'm going to kind of backtrack and redo from this point forward. So instead of finding common denominator to combine those fractions, we could have found that common denominator of sine squared x and cleared fractions in this manner. So we go ahead and multiply sine squared x on the top and on the bottom in this manner. Notice distribution is needed. So we quickly end up with cosine squared x minus sine squared x over cosine squared x plus sine squared x, which is equal to, again, the denominator is just 1, just cosine squared x minus sine squared x. And you should recognize this as one of the 3 different forms for the expression of cosine 2x, the double angle identity for cosine. So you could just say cosine 2x. So this, what we just showed, from here to here to here to here, is the fastest way you could have gone about proving this particular identity. All right, so that should do it for this video, and be safe until our next meeting.